my name is Tae Kyung, and the metric number is D0520100008. And next, before we present about the thyristor and silicon control switch, I would like to present the Stokely diode first, because thyristor and the silicon control switch are made based on the structure of Stokely diode. So the Stokely diode is made by the combination of the four-layer silicon, which are p-type, n-type, and p-type and n-type. So it is called a PNPN layer. So there are three junctions in the solid diode because of the combination of this four-layer silicon. So the test junction will make the Stokely diode consist of two transistors, which are PNP and NPN. So the Stokely diode has the characteristic of the transistor, and this is a schematic symbol. And when a voltage across the diode increase until the forward breakover voltage, and the value of current will achieve the value of switching current. This means that with the value of current increase until the holding value, and the value of the voltage will slightly decrease, and after the current exceeds the value of holding current, the value of the current in the diode will continuously increase, and the diode is in a forward conduction region, which means that the diode is in low resistance, and the current can flow through the diode freely. And before the voltage across the diode is lower than the forward breakover voltage, the resistance in the diode is very high, so the current cannot flow through the diode, and the diode is in off state.
Hello, my name is Daisy Chen. Now I will start my presentation. I will present the SCM, silicon control rectifier. A silicon control rectifier also is called thyristor. Mostly it's used for the control AC power, and also as auto on-off switch. The structure of SCM is similar with the structure of four-layer PN device, as we were discussing now. The structure of SCM has three terminals, but transistor has two terminals. This is the basic structure and schematic symbol of SCM. Now I will explain how to turning the SCM off. Although the gate current is removed, but the SCM is still operating and it stays in the forward conduction region. The only way to turn off the SCM is reducing the current that is flowing in from cathode to anode in SCM until a value lower than holding current. So SCM can be turned off when the current in it is below the holding current. There are two methods to turn off SCM: anode current interruption and forced commutation. Now I will explain how to turn the SCM off. We have said the SCM can be on-off switch, so it can be turned on as closed switch and turned off as open switch. SCR can be on or off in certain conditions. The direction of current is the direction of flow of electron. The common direction of the current is opposite with the direction flow of the electron. The SCR is turned off as an open switch when the current in gate Ig equals 0.
Hi, my name is Nur Hamizarina Anapupama Maham. So I am responsible to share about the applications of silicon control rectifier, as known as SCR. The first applications of SCR is SC power control. The phase control form of SCR by varying the triggering angle alpha at the gate terminal power control is obtained. The main advantage of the phase control is that the SCR are turned off automatically at every current zero position of SC current. And the second one is DC power control. Power delivered to the load is varied by varying the on and off durations of the SCR. This method is called as a chopper or on-off control. It is also possible to modify the SCR at certain triggering frequency in order that the current flowing to the load is varied. It is possible to supply the variable DC power to the load by using phase control rectifier circuit. And the third one is over voltage protection circuits. SCR applications is often employed as a protecting device. The circuit used for the protection against over voltages is referred as the crowbar circuit. Crowbar circuit consists SCR which is triggered by Zener diode arrangement. Thermal systems is one of the applications of SCR. The amount of electrical current load current supplied to the heater is set by the SCR power controller. The temperature controller's process output signal is sent to the SCR power control. Main advantage of SCR power controller is calculate the rate needed to switch electrical current on and off to the heater. And the second one is the switching is extremely fast, which resistant element experiences very small temperature variation. SCR power controller working in this firing mode is off if no input signal is present, otherwise it is fully on. And the last one is half wave power control. SCR application is in the control of SC power lamp dimmers, electric heaters, and electric motors. SCR can be made to trigger at any point on the positive half cycle the SC waveform between 0 and 90. When the SC input is negative, the SCR turns off and does not conduct again until the trigger point on the next positive half cycle. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and very good morning to Dr. Imran. Today, I will firstly introduce myself. My name is Ma'an binti Muhammad Isa and my matrix number is D0520101122. Today, I will present about the silicon control rectifier application. The first one that I will present is full wave bridge rectifier. Instead of using a central tap transformer, it is also possible to use 4 SCRs in the bridge configuration to get full wave rectification. During the first positive half cycle of the input, SCR1 and SCR2 are in a conduction. During the negative half cycles, SCR3 and SCR4 are in a conduction. The conduction angle of each thyristor is adjusted by varying the respective gate's current, and hence the output voltage across the load is varied. Next, I will explain about the over voltage protection using the SCR. The figure at this slide shows the crowbar circuit using SCR. This crowbar circuit is connected across the circuit or load which is to be protected. The circuit consists of SCR which is triggered by the Zener diode arrangement. The Zener diode is selected in such a way that under normal operating condition, it acts an open switch. The voltage across the resistor is zero, hence the SCR remains in off states, which means there are no overvoltage. But whenever the voltage of the supply sources exceeds the specified limits, the xenon diode starts conducting, and the sufficient voltage appears across the resistor. This drives the SCRs into a conduction mode. So, the voltage across the SCRs is reduced because it is in conduction mode. So, the conclusion is that the load is protected from the overvoltage. Lastly, I will explain about the sawtooth generator. The SCR can be used in a conjunction with an RC circuit to produce a repetitive sawtooth waveform. The time constant is set by R1 and C1, and the voltage at which the SCR triggers on is determined by the variable voltage divided from by R2 and R3. When the switch is closed, the capacitor begins charging, and they turn on the SCR. When the SCR turns on, the capacitor quickly discharges through it. The inert current then decreases below the holding value, causing the SCR to turn off. As soon as the SCR is off, the capacitor starts charging again, and the cycle is repeated by adjusting the potentiometer. The frequency of the sawtooth waveform can be changed. And that's all from me, thank you. And now I will pass to my friend Karimisa, and she will present about her point.
Assalamualaikum, my name is Karimisa. I would like to present about silicon control switch. Silicon control switch, also known as SCS, which is a four-terminal thyristor that has two gate terminals that are used to trigger the device on and off. For basic operation, first, if Q1 and Q2 are off, therefore the SCS is not conducting, a positive pulse on the cathode gate drives Q2 into conduction and provides a pulse for Q1 base current. When Q1 is turned on, its collector current provides base current for Q2, thus sustaining the on state of device. This regenerative action is the same as in the turn-on process of SCR and the four-layer diode illustrated in Figure A. The SCS can also be turned on with negative pulse on the anode gate. This drives Q1 into conduction, which in turn provides base current for Q2. Once Q2 is on, it provides a pulse for Q1 base current to sustain the on state. To turn the SCS off, a positive pulse is applied to the anode gate. This reverse bias the base emitter junction of Q1 and turns it off. Q2 in turn cuts off and the SCS ceases conduction as shown in Figure B above. This device can also be turned off with a negative pulse on the cathode gate as indicated in Part B. The SCS typically has a faster turn-off time than the SCR. In addition to the positive pulse on the anode gate or the negative pulse on the cathode gate, there is another method for turning off an SCS. Figure A and B show two switching methods to reduce the anode current below the holding value. In each case, the bipolar junction transistor acts as a switch to interrupt the anode current. For applications, the SCS and SCR are used in similar applications. The SCS has the advantage of faster turn-off with pulses on either gate terminal. However, it is more limited in terms of maximum current and voltage ratings. Also, the SCS is sometimes used in digital applications such as counters, registers, and timing circuits.